Hello and welcome. In this section, we will be talking about the basics of Unity and programming in general, because when we move on to making our game, we kind of don't explain how programming works and how methods that we will be using work. We assume that you know those things. So if you're a beginner in Unity, we made this first section for you, so you can learn everything that you need to know and then continue with our game development. But if you're familiar with Unity, you can skip all this and just start with making the game. Okay, so this is how Unity looks like when you open it. We have our game view, and this is the scene view. In the game view, you basically is the feed of the camera. So what the camera sees is going to be shown here in the game view. Your scene view might not look like this. Mine looks like this because I clicked on this icon here and disabled the skybox. I just like it to be black like this. I also have this Animator tab open here, but we'll talk about this later on. We can close it for now. And we have the asset store where you can purchase assets and things like that. In this course, we will provide you with all assets that you need in order to make a full game. So we'll be recreating the first Legend of Zelda. So we'll give you a character sprite sheets, enemies, environments, all assets that you will need. So here in my scene view, if I go to hierarchy, I can create game objects. And since I created this project as a 3D project, but it doesn't really matter. You can do the same thing in a 2D object. So if I go to 3D object and create a cube, you can see we have this cube here, and in our game view it's really far off to the distance. That's because it set its position to some random values. Let's center it. Now it's in the center, and you can see if I go to my scene view and select my camera, this is the game view that the player sees. But if I move this, we can see it here in the scene view, but in our game view we don't see it. That's because it's out of the side of our camera. Let's just put it back here. So this cube is a game object, and each game object has its own components. The most basic components that each game object will have is a transform. A transform is basically its transform in the world. So currently, each transform has a position, a x, y, and z, a rotation of x, y, and z, and a scale of x, y, and z as well. So currently this object is sitting on 0, 0, 0 on each of these coordinates and has a rotation of 0, 0, 0, and the scale is 1. We can of course rotate this object by changing these values here, or we can, in the scene view, press E and rotate it however we like. We can also press W, a shortcut, to move it around, and we can press R to scale it. We can drag all of these axes in a direction to scale it up, or we could drag the center to just scale it on all axes. Now we can't see this cube too good because of the skybox, so I'm going to go to the camera, and here we have, if the camera will look at a skybox or a solid color, I will select solid color so we have a better view of our cube. I'll call this cube maybe game object 1. Moving on, this cube also has a mesh filter. This basically says what kind of mesh this object has, so we can change these meshes, but I'm just going to leave it at cube. And we also have a box collider. Colliders are basically components that allow a object to be interacted with. So if you have two objects with colliders, they will hit each other and they can't pass through each other. So now in our box collider we can edit the collider, and if I go to our scene view, we can actually see these green lines here. That's the collision of the sphere. So if an object would hit these green lines, it would stop moving. We can also increase this collider like this, but this isn't really a real. This doesn't look real like a collision like this, because an object would hit this, but there would still be space to get to the cube. We can just reset these values to their default ones by changing the size. And we also have the mesh renderer, which just tells what kind of material this has and things like that. Currently, this game object has the default material, but we can create a new material and slap it onto this game object. That's really easily done in our assets browser. If I right click and go to create and navigate to material and click on that, I will call this material game object 1 material. And here we have, first thing, what kind of shader does this material use? Shaders are a complex topic, so I won't cover them in this course, but we'll make sure to create a new course that talks about shaders in the near future. But basically we have all kinds of different shaders for different uses. For example, particles. We can add shaders on we can add materials on particles to create amazing looking particle effects. We have a whole course on particle creation where we recreate particles from Legend of Zelda, Breath of the Wild, Wind Waker, Grand Theft Auto, and we actually take your feedback and create particles that you request from us. So that's you should definitely check that course if you want to learn how to create amazing particles. But for now, we will leave this shader to be standard. And I can just change this color to maybe black and bump up the metallic. And now if I drag this game object onto my cube, we will have this metallic cube. And we can also change these values here and see how the material changes on our cube. We can also bump up the smoothness. We can enable disable emission, but I'm not going to talk about this too much. I just want to show you how it works. And also, probably the most used component is going to be a rigid body. So we have a rigid body and a rigid body 2D. Basically, this component allows a game object to have to be in the physics world. So if I add this rigid body, we can apply force to this object. It can be affected by gravity. So if you check it out, it has a mass. So I can bump the mass up to maybe 50. And we also have use gravity enabled, which means if I run the game now, this game object should fall down anytime now. And you can see it's falling down because we enabled gravity. We also have the collision detection here, and we have the constraints, so we can freeze its position on one of the axis, and we can also freeze rotation, which is really great. You will be using this a lot, this component. So for example, if I create let's actually copy this game object, duplicate it, and I'm going to go to scene view and move it down, reset the rotation of this game object, and I'm going to now resize it. Okay, let me just see if we see it. We don't. Just going to pull it up like that, move it up. Okay, so that's going to kind of act as our ground. I will name it ground. So now if we go into the rigid body of this object and disable use gravity, this cube will fall onto it, but it won't stay there. It will actually push it down. You see, because it applied force to, and you see how they react in the physics world. That's because our ground has also a low mass, and that's how objects behave. But we can just set this object to be kinematic to be true. That means that nothing will move it. So you see now our cube fell down and it's standing there. These are kind of the basics of the inspector and the basic components. In the next lecture we will be talking about coding and the basic data types and things like that. So thank you for watching, and I'll see you in the next lecture. Hello and welcome back. Today we'll be talking about creating scripts in Unity and the basics of programming, mainly the 3 basic data types. So I'm going to right click in our assets browser and create a new C# script. I will call it just maybe test. And now we can open it. We actually have a preview of our script here. I'm using Visual Studio as my text editor, but you can also use MonoDevelop. It doesn't really matter. The code works the same. I just like how Visual Studio looks, and I'm used to using Visual Studio. We'll wait a bit while this loads. you can see that when you create a script, we have these previews here, and it already came with some code. This is basically, it just created kind of like the, let's say, stepping stones for you that you will build on. So we have these 3 using tags. This basically means that we're using system.collection, the libraries from these. So we're using methods from these libraries, so we can also import later other libraries and use methods from them. For example, if you're building an Android game and you want ads, you'll need to say using Unity Engine.advertisements to be able to call ads in your game. So we can see we have our class here, which is called test, and it's of type monobehavior. And we also have these 2 methods here made for us, start and update. Basically, start method, we have these curly brackets here. So if we type in some kind of code here, that code will execute at the beginning of the game. So when the game starts, void start is called once, and when all the code is executed, we never call this again. Void update is called each frame, as this comment here says. So each frame we will execute code in here. We can add comments by doing these double slashes, and I can say this section of the code is for movement or things like that. And when somebody looks at my code, he can read the comment and say, ah, this is for movement, and it's easier to read. So to start off, the 3 basic data types that we have in C# is going to be a boolean. We say boolean, which is the type of the variable. These booleans can be either true or false. So we can say boolean, let's call it variable bool, and we can set the value of this variable here when we create it, so maybe false. Then we have a string, which we can call maybe name. We can also set the value of this string here to be Steven. And then we have integers, floats, oops, sorry about that. We can call this number. We can also set the value of this number to something. Now what I want to do is when the game starts, I'm going to print out these values. We can print out in Unity by saying debug.log, and in here we say what we want to write out. So we can say variable bool, and we need to end each line of code with the semicolon. So basically when we start the game, it should say false because it's going to debug the contents of this variable. So basically variables are kind of like buckets in which we place some kind of contents. So this variable contains the false information. So when the game starts, we should get a false. Down here in our console, we should get false printed out. But for some reason, oh, of course, currently we made the script and it's not attached to any game object, so Unity doesn't know what to do with it. Should it call the start method? So we can select one of these game objects. For example, this game object 1, which is this cube. And just as we added these components, scripts are also components. So we can add this, drag the script to the game object, and now it will be called because it's part of this game object. Just like this rigid body is a component, so is the script. So you might also have scripts that are like player movement, and those are components of the player that make him move. So now if I run the game, we get false. We can also debug this other information. For example, we can debug.log name, it should say Steven, and we can debug.log number, which should say 2 when the game starts. And there we have 2. We have Steven 2, and we have false. Okay. But another great thing is these variables here are static variables, which means they can only be accessed by this class, test. But if we say public bool, public int, and public string. That means that other classes, other scripts, other game objects can access these variables, and also in our inspector, we ourselves can access these values. You can see we have this tick box for the bool variable. This is false, this is true. We have the name, I can change it to Kevin. We have a number, I can set it to 10. And now if I run our game, we should say get false, false, Kevin, and 10. Okay, let's just delete these, since we are setting the values from our game. Okay, that works great. So the difference between start and update. Now in our start, if I cut this from the start method and put it in the update method, each frame we will get the variable, concept variable, the name, and the number. So if I save and go back into Unity, I'm getting some warnings for line endings, you can ignore those. So if I run the game now, you can see how it's debugging this like 200 times already, false, Kevin, and 10. So those are the difference between update and start. But we could also create our own method. We can say void print buckets, so to print the value of these buckets, these variables. And in here I can just copy the code that we had in update and start. Now this method won't do anything because, well, it would do this, but we never call it. So if I start Unity, if I first clear out my console, and if I start Unity, nothing is debugged. But now we can call the method print buckets. We just say in start maybe print buckets and these brackets, the semicolon. Now when the game starts, we should print those values once. So we get false, Kevin, and 10 printed out once. But if we were to call print buckets in our update method, you guessed it, we would get these values each frame. Now if I say we get Kevin and 10. Also I can change these values while the game is in play mode. So if I set 15, it started printing out 15. And I can say Michael, I misspelled Michael, doesn't matter. So you see it prints them out. But when you're in play mode, please keep this in mind. If you're in play mode and if you make any changes to these values here, and if you add maybe more game objects to the game and things like that, and then you exit play mode, all those changes are reverted. So you could see I made another game object, it's deleted, and if I go back to my game object 1, the name is Kevin and the number is 10, even though I changed them. This can happen, this happens to a lot of people, happened to me a lot of times. You just creating a level and you forgot that you're in play mode, and then you lose all your progress. So please keep that in mind. I think if we actually go to edit, I think it's in preferences. Yes, if you go to color, we have the play mode tint. So you can set this to some color that's going to hurt your eyes. So you just know that when you play, I'm in play mode. So you can never get that. You can never get that, make that mistake. But I'm just going to go to preferences and set my color to be something nice, like this blue. Okay, that's going to be it for this lecture. I will see you in the next one, and thank you for watching. Hello and welcome. In this lecture we'll be talking about if statements in C#. So basically, if statement is kind of a statement that if it is met or isn't met, some kind of code will execute. So basically it goes like if, and then we open up brackets, and this is where we want our code to happen. And here as conditions we can have many things. For example, variables, integers, booleans, and strings. One example would be if variable bool, which can be either true or false, I can say is true. Now notice here I'm using two equal signs. Well, two equal signs are used to compare if this variable has this value inside of it. If you remember, for assigning we used variable bool and one equal sign. This means that if when the game starts, we will set variable bool to be true, and then here we say if this is true, then we execute some kind of code. What kind of code do we execute depends on if we have nothing after the if statements. So this means that the next line of code will be executed. But if we have kind of like curly brackets, like this, then this means that everything inside these curly brackets would be actually executed. So we could say something like debug.log hello, and we could also change the value of maybe number and set it to 2. Now if I save this, I can actually delete this variable bool here, and I will just demonstrate something. And if I go back into Unity, if I can click on my ground just to see if my script is attached, and it isn't, so actually the game object 1, and it is. Now variable bool is set to false, as you can see here. So that means that we shouldn't call the method print buckets, and we will be updating this each frame. So each frame we're saying if variable bool is true, we want these things to happen. Then we will call the print bucket method, which basically prints the value of variable bool, our name, and a number. If we go back into Unity, we can see that the number is 10 now, but if you remember, if our if statement is met, it will be changed to 2. So now if we run it, nothing should be debugged, okay. But if we change variable bool here, you will see we get true, Kevin, hello, and 2. So first, because how it works, it goes, first it does this, then this, and then this. So it first printed out all of these values, and the number was 10, and then number was set to 2, so it was changed, and you can see 10 was called once, but 2 was called 500 times. We can now close this. I will clear my console. Another thing we can check after if statements, we can say else. So when this isn't true, we want to do something different. So we can say a variable, I will now, okay, else, what could we say? We can also have one line, like number is equal to 5, or we could do the open up curly brackets, if I can find them, and then we can say in here number to 5. So now what we're going to do is, when this is true, we will print these values, and first number will be 10, then we set it to 2, and then when we reset this boolean and then enable it again, number will be 5. So now if I run my code, so now what it does, it checks if variable bool is true, but it isn't, so it does this code, so number is set to 5. So if we enable our variable bool, if we set it to true, we will get once 5 and 2 other times. Let's clear this again and go back into Unity. Also, we can say else and have another statement, else if number is equal to, we can say greater than or equal to maybe 12, we will say debug.log more than 12. So now if we save this, we're going to run the game and nothing is happening. So this code isn't executing because our number isn't greater than or equal to 12, it's 10. But if I set it to 15, we have more than 12. But then if I set variable bool to be true, we print out our usual things, and more than 12 isn't printed out. So we can disable it, and again set no number is 2, so we don't print anything. But if we set it to 15, we start getting more than 12. So that's basically how if statements work. Thank you for watching, and next time we will cover more loops. See you then. Hello and welcome. So last time we spoke about if statements, and now I'm going to show you a for loop, which is going to be very useful in our game development. So the for loop goes like for, and then we have these brackets, and then we can open up curly brackets to add code in here. And this loop, the statement here in this loop is kind of contained of 3 parts. So first we declare how the loop starts. So we say int I mostly is equal to 0. So we're going to start with this integer, and its value is going to be 0. And then we say this is going to loop until this condition is met. So we're going to say this will loop until I is less than or equal to, we can say number. And each time we loop through this, we're going to increase I by 1. And now in here we can just call our print bucket method. So if I save this and go back into Unity, if I select my game object and now see that our, let me just delete all of this, the number is 10, we should get that the code executed 10 times. So now if I start, we get print buckets 11 times. Well, that is because I starts from 0, but the number is 10. So if you count that up, that's 11. So what we usually do is subtract number by 1. Whoa, I have insert turned on, sorry about that. And now we should get this printed out 10 times, but first clear our console so it doesn't confuse us. And we get 10. If we change the number to maybe 5, we would get 5. Okay. Now this is really useful if you want to get the length of a string really quickly. So now we can say, instead of the condition to be number minus 1, we can say name.length minus 1. So we're going to compare to start from 0 and until I is less than or equal to name.length. So basically if our name is Sven, that's 1, 2, 3, 4 characters, and we can say number plus plus, and we can start by setting the number to be 0 up here in the start method. Don't set number to be equal to 0 in the for loop, because then it will always be set to 0, and until it loops, number will be set to 0. Now if we go back into Unity, make sure we set number to 0 also in here, and if we run, nothing is happening. Oh, actually we get our number here shown because we didn't debug log it, we just saw the change here. We get 4. And now if I type in something really long, I start, and I don't have to count up the string, I just know it's 28 characters, which is really great. We will be using this a lot in game development. So that will be kind of a basic explanation of the for loop. Next time we'll talk about some object-oriented programming, and then we will be able to move on for game development. Thank you for watching, and see you then. Hello and welcome. So today we will be speaking about some basic object-oriented programming things. So basically what that is we will have two classes, two scripts that can talk to each other and other objects. So let's go ahead and create a new C# script. I will call it second script. And now I can open it up and reload all. And now let me wait for it to open my second script. Come on, Unity. Okay, here we go. And now we need to get a reference to the test script. We can do this easily if we set both the scripts to be on the same object. Whoops, I'm going to go to here, and I can say public. Actually, it doesn't need to be public because we're on the same game object. I can say test, so that's our script, and I can call it test script. I can actually let's call it first script. And now when the game starts, we want to say first script equals get component test, and then these brackets. So basically when the game starts, we make sure to get the script, the test script, and put it kind of like, we put that object in this variable. And now I can say in my update method, I can reference, I can say if, and say first script, and now I can, if I set dot, I can access the variables from the public variables from the script. So I can say if variable bool, and you can see it's suggested here. This by default is going to check if variable bool is true. We don't have to say two equal signs and true. And also if we put an exclamation point in front, this checks if it's false. So we're going to say if variable bool in the first script is true, I'm going to Well, now we can't call this method because it is a private method. But if we say public void, we should be able to call print buckets. So I can say first script dot print the buckets and just call that method. So now we check if it's true. Okay, so now if I save this, go back into Unity. Now this is false. Let me just clear these warnings. So it's false. If I turn it on, we get our prints from the other script. So this is kind of cool, right? But we can also do this from different objects. So let's remove this component from the GameObject1 and let's rename it to cube. And let's go to the ground and add it here. Now we can't actually, whoops, again. From our second script, now we can't get the component test because when you say it like this, it just tries to get it from this game object. So now instead, we have to do a bit of kind of differently. So we can either say here public test first script and go back into Unity. And then here we should get a, now like we have for our variables, now it's waiting for your script. We can just just get the test script. Actually, we have to get it from the game object cube. We just put it in there. We put the whole game object and it knows that test is on there. Now if I clear, we get a null reference warning. And that is because, let's see, whoa, sorry about that again. Get component test. This doesn't seem to be working properly, but the method I wanted to show you, which definitely works, is we say GameObject.getComponent. Actually, find GameObject with tag, and then say getComponent. Sorry, getComponent and test. And also in here we have to put the brackets. So find GameObject with what tag it's asking. I'm going to just set this to be player temporarily. So in this script, we're going to find a game object that is called player, that has the tag player, and then from then we get the component test. So now if I go back into Unity, currently nothing has the tag player, but if I click on the cube and go to tags, I can change the tag to be player. And now if I run the game, we can also reset the public to be just this, a private. So now if I run the game, I can, now the ground has the second script, cube only has this one. So if I turn this on, we get these prints. Okay, so that's really awesome. So you see how we start referencing other scripts since they're components. We can also reference all of these components. So for example, I can say mesh renderer and get a reference to this component by, let's call it mesh r. And now when the game starts, we simply need to get this component by saying mesh r equals get component, and we want to get the mesh renderer. Okay, and now when we have the mesh renderer, all of these components here, we can access them through this variable. So in the update, I can say if input.getKey down. So this basically checks for a key press. So I'm going key code space. I want to say mesh renderer dot enabled and set it to false, because actually it's set, let's say enabled and set it to false. So now if I look at my cube here and I start the game, if I hit space, we disable the mesh renderer and we can't see our cube anymore. If I re-enable it again, there's our cube, and I hit space again. So you see how we're getting these components, these objects, and this is a crucial thing in game development, since we're going to be getting references to rigid bodies, to apply force, to the box colliders, to the animators, and all those things. So this is kind of the basics that you need to know to get started with the next lectures. So thank you for watching, and see you next time when we start making our game.